So let's ask these questions now. Whether the primary mechanism of heat transfer is conduction, convection, natural or forced, radiation, and then we'll have to briefly explain, okay? So what we're going to do is we're going to use the number 1 for conduction, the number 2 for natural convection, 3 for forced convection, 4 for radiation. Energy from the sun reaches Earth. Go ahead and vote on that. What is that? 1, conduction, 2, natural convection, 3, forced convection, 4, radiation. You guys, how come no energy can reach the sun, reach the Earth from the sun due to conduction? It's not touching. There's a vacuum between them. Same reason that you can't have convection. There's no gas between them. There is some particles out there, but it's pretty thin out there. So the only way that it can do it is by radiation. That is number 4. That's how we get all the energy from the sun. Radiation. There's no gas between the sun and Earth. I mean, there's a few particles out there. It's like a couple molecules per cubic meter, but it's not enough to have considerable effect. Okay, water boils a lot faster when heated from below. In fact, you can't boil water if you try to heat it from above. You can put a bucket of water under a heat lamp. It will never boil. It may evaporate away, but it'll never boil. What is the important process when you boil water? You need this to happen. It is which one? Natural or forced convection? 2 for natural, 3 for forced convection. Which one is it? You know, you put a flame below it, it heats it up, but then that water rises throughout the whole bucket of water, the whole pot of water. So that is natural convection. You cannot boil water from the top. You get burned when you touch a metal spoon left in a pot of boiling water. Here's a better example. There's a spoon in an oven. You touch the spoon, you get burned. You put your hand into the oven, surrounded by air, you don't get burned. In fact, you go, wow, it feels nice. Which factor is that? Conduction. That is conduction. The heat can leave the spoon a lot easier than it can leave air. Coolant flows through your car's engine block to the radiator, pushed by a water pump. Go ahead and put 1 for conduction, 2 for natural convection, 3 for forced convection, 4 for radiation. Primary method responsible is forced convection. That's what the pump does. Forced convection. Your car's water pump breaks while your car is still running, so coolant doesn't flow. Which one, if the coolant stops flowing, which one is it? Go ahead and vote. It is, there will be some energy transferred by conduction, but that doesn't last for very long. Pretty soon the motor will be in blank with the coolant. Thermal equilibrium, and then it cannot cool it down anymore. So they will both continue to get hotter and hotter and hotter. So what happens is, by convection, the coolant is brought through the radiator, which blows air by it and cools the coolant. Night vision goggles are based on this. Which one is it? Go ahead and vote on that. Night vision goggles, because everything that's not at absolute zero gives off radiation. This is radiation. It gives off radiation typically in the infrared range. And you don't have to be white hot for this to be true. You can see people, animals, or any object that's not at absolute zero with night vision goggles, because they're all giving off infrared or thermal radiation. A lit incandescent bulb burns you when you unscrew it from the socket with a piece of foil protecting your hand, but not with a piece of paper protecting your hand. Which is the methodology or heat transfer method that allows this to be true? Conduction, because what variable is different for paper and foil? K of paper and K of foil. What symbol do I have to put between those? It is less than.
Paper allows a slower rate of thermal energy transfer.
A lit and incandescent bulb gives off light because of this. It is radiation. So here is why incandescent bulbs are so dumb. It's like, let's heat this thing up, and then, oh, we get some light as a byproduct. Mainly you're getting heat from incandescent bulbs. In fact, about 90% of the energy of an incandescent is Thermal energy.